Today we have a Gat FOB that the owner said it did a dip in the pool, so I don't have much hope on this one. So let's open it up and see how it looks inside. So we start by removing the 3 Phillips screws. So let's open it up, and yeah, this looks awful. Well, we will do it just for the video, but I'm 100% sure that this will not work after we clean it and test it. So yeah, we have corrosion basically everywhere. The solder mask is already peeling, so we will have corrosion under the board as well. Well, let's do something. We'll start by removing the old batteries that are all corroded, as you can see. This takes 2 CR 2016 batteries, which are the ones here we are removing. And as you can see, there's a lot of corrosion and rust. So the lead is also corroded on one of the sides, so I will say this is busted as well. And here it's very tricky. The chlorine on the pool corroded everything, and the water stood inside for a while too. So let's dip it now on isopropyl alcohol and brush it with a toothbrush, not very hard to avoid removing any components, but we are removing the solder mask already. Some parts are just jumping out. It looks now a lot better. Hopefully we can do something with it. Let's just verify the legs of the ship if they are solid still. And we wipe it with a cotton bud to make sure to remove any of the remains of corrosion. We will cover now the buttons with Kapton tape in order to remove the battery holder. Let's use a bit of flux with our iron at around 350 degrees and the solder sucker. We will then remove the old solder to take this out. Same procedure on the other side. So upon removing the battery top, we have now a lot of corrosion under the batteries, and as you can see by brushing, we are removing the solder mask. Let's do a run for shorts to see if we find anything. So one of the components already jumped out, the one that was closer to the battery area. So it looks like a capacitor, which should be, because it's marked as a C on the board. So let's keep on going. Let's test the LED on diode. It should light up if it's working. If not, it won't light up. And this is the capacitor that came out, so it's not a continuous path, so it should be working. And in resistance, it shows resistance, so should be okay. So let's use a bit of sodium bicarbonate. I'm not sure what the name is in English, but it's a powder that reacts with vinegar to remove the rust. It's good. And here we will then try to place the capacitor back. So we will use a bit of flux and our iron at around 300 degrees to melt the solder and clean the area. Let's add a bit of unleaded solder to get the pads to shine again. Let's clean it with a cotton bud. As you can see, the solder mask continues to be removed, which tells me now we can see the corrosion under it. So I don't think this will have a good end, unfortunately. So we managed to adhere the capacitor, so let's make sure it gets solid with our hot air station. I have set it at around 350 degrees with a airflow of 50%, and let's hope it fixates it. I can hear the bottom popping, which should be the buttons, so I will need to stop the airflow, otherwise this won't work. So as the airflow didn't work, let's add a bit of a bit more solder to this area and see if the capacitor can be fixated on place. It doesn't look that good. I think it should not be a capacitor. It reads an L there. What's an L? I don't know what an L is. I would assume it was a capacitor. It probably isn't. But anyway, it's there, and let's see if this will work eventually. So I will apply a bit of flux everywhere, and we will touch with our iron around every single SMD to make sure they connect properly. So again, with our iron at around 350 degrees, let's touch every single SMD in order for the solder to flow and make sure it is connecting with the SMDs that we have on the board. And we do another clean on this area so that we finish removing all the solder mask. Using our green solder mask, let's then pass it on through every part that was removed when we cleaned. We will now use our UV light to dry it up for like 3-4 minutes. It is now dried up, so let's go and assemble the battery cover on it. First we need to remove it from the sodium and the vinegar and clean it. The rubber part looks much nicer, and the metal part, it looks horrible, but let's use our Dremel to make a good clean out of it. So let's check for continuity in all the points that we needed to have continuity. And we now place it back. So let's use flux for our solder to flow, heat up the area with our iron, and add solder in order for the ground spots to be very well fixed. Same thing on the other side. Let's then check for continuity to see if we have a continuous path from one side to the other. Two brand new CR 2016. Let's then place them and see if we have any results. As expected, the LED does not turn on. I am not sure if this is doing any signal, but it should not be. Let's just test for voltages to see if we have 3 or 6 volts somewhere on the board. So we do have 2 volts here, 2 volts here, 8 volts. It should be 6 volts maximum. We don't have any readings on the cap that got loose. This is a ground side. Here you have 6 volts, which is in pair to 2 batteries. 6 volts. So yeah, voltage is going in. I was not expecting that either. So yeah, most of the areas of the board does have voltage. Let's just do a quick test on the LED again, and it's not showing anything. Well, it doesn't have voltage because the buttons are not pressed, but let's see with the diode mode. Diode mode does a reading but does not light up, so I would say the LED is broken. And yeah, this is it. Unfortunately, we were not able to fix this one. I didn't have any hopes on it anyway. So, hope you enjoyed the video. If you did, give it a thumbs up, leave a subscription, and I'll see you on the next video. See you all.